Now, side-side angle triangles are going to be a little bit harder to draw accurately, but still try your best. So we're starting here with an angle alpha that is about 30 degrees. So I'd say it's pretty close to 30 degrees. I have the A side, so that should be across from it, is 1 unit. And one other side is going to be 4 units. So I'm going to say that's C. So that would make this gamma, because they're across from each other, which would make this B and this beta, so that they're across from each other. So once again, I notice very quickly I have side, side, and an angle that is not between them. This is side, side angle, which means we need to do our test. To do our test, you always start by finding the angle you can. So we use our complete pair, sine of 30 degrees over 1, to solve for gamma. That's the only one I can find because I know C. I don't know anything about the B's, so I can't solve for them yet. So sine of gamma over C, over 4, there we go. Now solve this in whatever way you want to. I usually do cross multiplying. 1 times anything is itself, so I don't really need that 1 there. And then I do arc sine of both sides to get gamma by itself. Now you'll notice when you go to type this into your calculator, you'll get a very distinct answer. This gives you an error. The reason it gives you an error is because this triangle actually isn't possible. If you really try to draw this triangle accurately, you cannot make these sides all meet. So this is actually just a D&E. So I wanted to do that as an example to show you that you can get D&E answers here. They are pretty rare, but if you get an error in your calculator, that is a possible answer. Let's go back to example 5 and do one where we're not going to get D&E this time. So this is a similar problem. I start with alpha equals 30 degrees, except this time A is a lot longer. So I have A is 3, C is 4, there's my gamma, B, and my beta. First thing I noticed, this is side-side angle, so I have to do my ambiguous test. That starts by finding the only angle I can, which in this case, same as before, is gamma. So sine of 30 degrees over 3 equals sine of gamma over 4. Now that we've solved one like this together, I would like you to pause the video and try to solve for gamma on your own. Just gamma. Don't try to finish this whole problem. Just solve this equation for gamma. Come back and check your work. Let's see what you got. I got that gamma is 41.81 degrees. Now, because this is side-side angle, at this point I have to do my test. So here is my test. I do 180 degrees minus the angle I just found plus the angle that was given to me originally in the problem. If I put that in my calculator, I get 168.19 degrees. If this is greater than or equal to 180, you only have one triangle. However, this is less than 180, which means I have two triangles here. So right away what I'm going to do is draw a big line here. I'm going to label all this triangle number 1. And I'm going to label all this part triangle number 2. So we have two completely different triangles here. The first one has this gamma. The second one is where gamma is obtuse. So to find that gamma, we do 180 minus the gamma we found. which will give us 138.19. And now you're going to solve this as two totally different triangles. So they both have this pair in common, both triangles. They both have C equals 4, but gamma equals a different one in each one. So now that you have C and gamma solved for, you're going to do your 180 rule to minus the two angles that you know. And we're going to do that for both of these. And that should solve us for beta. Then you can do law of sines with the pair we know and with the angle you just found in beta to solve for b. So I would like you to pause the video, try this out on your own, do the 180 rule for both to find the two different betas. Then you'll set up two different law of sines to solve for b. Pause the video, try that out, and then come back. So for triangle number 1, I got that beta is 108.19. For triangle number 2, I got beta is 11.81. And then for triangle number 1, I got b is 5.7. And triangle number 2, I got b is 1.228. Now I tried to draw two triangles so you can kind of see what's happening here. I have this triangle, which is our triangle number 1, where beta is obtuse and gamma is acute. Then I can take this orange side, a equals 3, and I can swing it inside to make my isosceles triangle right there. And if I swing it inside, now I get this second triangle. Still has the same three pieces of information I started with, but now beta is acute, gamma is obtuse because that A side has swung in to create a different triangle. So that is our first example of the ambiguous case. Basically, anytime you have side-side angle, you have to do this test. If it's less than 180, you've got two completely separate triangles you have to solve for. If it's greater than or equal to 180, there's only one triangle. Let's try one last example with this ambiguous case. Same thing, I have alpha equals 30 degrees. And this time, C is 4 and A is 4. I didn't draw this one very good. So this is the one where I want you to start to try to do this on your own. I want you to solve for gamma first. That's the only one you can solve for right now. Use the law of sines to solve for gamma. This is a side-side angle, two sides, and an angle not between them. So we will do our test. So once you solve for gamma, then do the test. Remember, if it's less than 180, you have two triangles. If it's greater than or equal to 180, you have one triangle. So solve for gamma, do the test on your own just to figure out how many triangles I've got here, and then come back to check if you did that part right. Hopefully you pretty quickly noticed that this is a unique triangle because I have two sides that are the same length. I actually have two angles that are the same length. This is isosceles. So if you go to solve for gamma, you get that gamma is 30 degrees. So I do 180 minus the angle I found plus the angle I was given. That gave me 180, which is equal to 180, which means I only have one triangle. Thank goodness. So let's do our 180 rule to solve for beta. 180 minus the two angles I've got gives me that beta is 120. And last thing, I want you to pause the video, do law of sines to solve for b, and then you're finished. So pause the video, solve for b on your own, come back to check your work, and then we'll be done with the ambiguous case for today. There we go. I got B is 6.928, and because there's only one possible triangle here, I am finished. So that is 3 different examples with your ambiguous case side-side angle where you have to do your test. In the next 2 videos, we're going to do some application problems using the law of sines.